Alright, so good evening everyone. We'll now be discussing our fourth module for our subject, and this is all about measuring performance. As per the learning objectives or outcomes, so we're gonna be understanding five main points. So we needed to understand the importance of performance measurement in computer architecture. We'll be familiarized with the key performance metrics and benchmarks, analyze the impact of hardware components with regard to the system performance, gain insights into optimizing and evaluating program performance, and finally, develop critical thinking skills to make informed decisions in our system design. As per the outline of discussion, so I divided this one into six parts. First part of the discussion is related to introduction, definition of performance in computer systems, significance of measuring performance in computer architecture, what is the connection between the performance and user satisfaction. So definitely important yan. And then part 2 is all about key performance metrics. So ano ba yung mga point of measurements that we needed to consider for computer architecture. So andyan yung clock cycle time, and number of instruction, the MIPS or the million instructions per second, and also the MFLOPS, which is the million floating point operations per second, the CPI, cycles per instruction, and IPC, which is for instructions per cycle, along with response time and throughput. Also, we'll be talking about benchmarking, the definition and purpose, what are the common benchmarks in computer architecture, what are the challenges and considerations in benchmarking. Part 4 will be talking about hardware components and performance, the CPU performance and the factors that influences it, memory hierarchy and its impact on the performance, storage devices in their role in the overall system speed, networking and input-output performance considerations. Next is program performance optimization that talks about compiler optimization techniques, code profiling and performance analysis, parallelization and its impact on program execution. Then we'll be talking about real-world case studies like examination of performance improvements in specific architectures, discussion on how companies optimize their systems for better performance, and emerging technologies, impact of the new technologies and performance measurement, integration of AI and machine learning in optimizing system performance. So let's now define performance. Performance in computer systems refers to the speed and efficiency with which a computer executes tasks. It is a critical aspect of computer architecture as it directly influences user experience and system responses or responsiveness. 'Di ba syempre kapag yung ating computer mabilis and efficient siya, so definitely mas marami siyang tasks or operations that it can perform. At dahil doon, mas okay siya para sa user. And then, in terms of the importance of measurement, it is crucial for several compelling reasons. It helps in evaluating the efficiency of a system. We could identify the bottlenecks, yung nagpapatagal dun sa proseso, making informed design decisions, and ultimately ensuring that the computer system meets user expectations. And sabi ko nga kanina, there is a correlation between performance and user satisfaction. Users expect systems to respond quickly and execute tasks efficiently. Kaya nga 'di ba, kaya nagkakaroon ng mga version. So dumadami ng dumadami yung ino-offer na series of versions para ma-upgrade yung needed ng ating users. So therefore, understanding and optimizing performance are fundamental aspects of computer architecture and organization. So for us to measure the performance, sabi ko nga kanina, meron tayong different criteria or ways to check on that. One is the clock cycle time. The time it takes for a processor to complete one cycle. Shorter clock cycle times generally result in higher performance. Kaya nga 'di ba dapat mas lumiliit ng lumiliit yung clock cycle time natin. Para ibig sabihin noon, mas maraming powerful yung ating processor para matapos yung mga instructions na pine-perform niya. We also have the MIPS and the MPLOPS. So yung MIPS natin, it measures the speed of a processor in executing instructions. Unlike yung MPLOPS naman, it measures the speed of floating point calculation. Siyempre, yung floating point talks about yung mga with decimal places na. The CPI is the average number of clock cycles per instruction, and IPC is the reciprocal of CPI, indicating how many instructions are executed per one clock cycle. Response time is the time it takes to complete a task from the user's perspective, while throughput is the number of tasks completed per unit of time. Benchmarking involves comparing the performance of a computer system against a standard set of programs or benchmarks to assess its relative performance. The purpose of which is that evaluating and comparing different computer systems or configurations, aiding in decision making for system design, upgrades, or purchases. Common benchmark example would be SPEC, or the Standard Performance Evaluation Corporation, which is a non-profit organization that develops and maintains a set of standardized benchmarks to evaluate the performance of computer systems. Spec benchmarks are widely used in the industry to measure the performance of CPUs, compilers, and parallel processings. TPC benchmarks for database system is another example. So TPC, or the Transaction Processing Performance Council, is a non-profit organization that develops and maintains a set of benchmarks for measuring the performance of transaction processing systems, typically database management systems. And graphics benchmarks like the 3D Mark. So graphics benchmarks such as 3D Mark are tools and suits designed to assess the performance of the graphics processing units, or the GPUs, and overall graphics subsystems in computing devices including PCs and gaming consoles. As per the challenges, selecting representative benchmarks, ensuring fair comparison, and accounting for real-world usage scenarios are some challenges in benchmarking. CPU performance. The architecture and design of the CPU significantly impact system speed. Factors like instruction set architecture, pipeline design, and cache hierarchy play crucial roles. So ano po mang ibig sabihin ng pipeline? Pipeline is a technique that enables the concurrent execution of multiple stages of instruction processing to improve overall instruction throughput. A pipeline breaks down the instruction execution process into distinct stages, and each stage is handled by a different segment of the hardware. Cache hierarchy refers to the organization and structure of different levels of cache in a computer system, typically including multiple levels of cache memory with varying sizes and speeds. The primary purpose of cache is to provide fast access to frequently used data and instructions, reducing the time it takes for the CPU to fetch information from slower main memory. The organization of memory, including cache, main memory, and secondary storage, influences how quickly data can be accessed and processed. The speed and type of storage devices, as well as the efficiency of networking components, contribute to the overall system performance. Achieving optimal performance requires a balanced design where CPU, memory, storage, and network components work harmoniously to meet the demands of the system. The compiler organization. Compilers translate high-level programming code into machine code, and compiler optimization techniques aim to improve the efficiency of the generated code, resulting in faster execution. Code profiling. Tools for code profiling analyze program execution to identify performance bottlenecks. Profiling helps developers understand which parts of the code consume the most resources. Breaking down tasks into parallel processes can significantly reduce execution time. Parallelization is a key technique for optimizing the performance of programs, especially in multi-core or distributed computing environments. These are some of the real world case studies, one of which is examples of optimization. So we could explore cases where companies or projects successfully optimize their systems. So this could include improvements in hardware design, software optimization, or a combination of both. We could also discuss specific strategies employed in the case studies such as redesigning algorithms, utilizing hardware accelerators, or implementing efficient data structures. We could also analyze lessons learned from the case studies, including the challenges faced, unexpected outcomes, and how these experiences can inform future system design decisions. As per the emerging technology, so there's an impact, of course, of the new technologies. So we could explore how emerging technologies like quantum computing, which refers to revolutionary paradigm of computation that utilizes the principles of quantum mechanics to perform calculations. Unlike classical computers that use bits zeros and ones, quantum computers use quantum bits or qubits. Qubits can exist in multiple states simultaneously, to a phenomenon called superposition. Additionally, entanglement allows qubits to be correlated in a way that the state of one qubit directly influences the state of another, even if separated by large distances. What about neuromorphic computing? So it is an approach to designing computer architectures inspired by the structure and function of the human brain. The goal is to create computing systems that mimic the way biological neural networks process information. Neuromorphic architectures often involve the use of artificial neural network or ANN, which are composed of interconnected nodes or neurons that perform computations and communicate with each other. And we also have advanced materials that refer to substances engineered to possess specific properties that go beyond those of traditional materials. These materials often exhibit unique physical, chemical, electrical, or mechanical characteristics that make them suitable for applications in various industries, including electronics, energy, healthcare, and manufacturing. So these three items, quantum computing, neuromorphic architectures, and advanced materials may impact the way we measure and achieve performance in computer systems. Along with the emerging technologies, of course, discussing of how artificial intelligence or AI and machine learning techniques are being employed to optimize system performance such as predictive algorithms for resource allocation and adaptive system tuning. So pag sinabi natin predictive algorithm, so this is for resource allocation that involve using historical data, machine learning, or statistical models to forecast resource requirements and distribute resources efficiently. These algorithms aim to optimize the allocation of computing resources such as CPU, memory, storage, and network bandwidth, ensuring that applications and services receive the necessary resources to meet performance goals. Adaptive system tuning involves dynamically adjusting system parameters and configurations based on real-time feedback and predictive analysis. These algorithms aim to optimize system performance, energy efficiency, and resource utilization by continuously monitoring and adapting to changing conditions. Highlight the performance of staying informed about technological advancements and the need for adaptability in the ever-evolving field of computer architecture is also vital in emerging technologies. In summary, this lecture discussion delved into the critical aspects of measuring performance in computer architecture and organization. We covered key performance metrics, benchmarking, the influence of hardware components, program performance optimization, real-world case studies, and emerging technologies. Understanding these concepts is essential for computer engineering students to design efficient and high-performance computer systems. As per the conclusion, so reiterate the importance of performance measurement in computer architecture. We also emphasize the role of continuous learning and adaptation in the dynamic field of computer engineering. We encourage students also to explore further research and practical applications in optimizing system performance and highlight the relevance of these concepts in the broader context of technological advancements and the ever evolving landscape of computer engineering.